I am excited to welcome you to Mathematics Simplified. My name is Joseph Jacob. Today, we are going to focus on adding, subtracting, multiplying, and dividing fractions. Let's start with addition of fractions. When you want to add two fractions, there are two things you need to consider. The first thing is whether the fractions are like fractions. The second one, whether they are unlike fractions. Like fractions are fractions that have the same denominators. If they have the same denominators, you don't need to start looking for their LCM. Solving for that fraction is just simple and straightforward. For instance, if you have 1 over 2 plus 1 over 2, you are trying to add these two fractions. They are like fractions because their denominators are the same, and the denominator here is 2. So what you need to do is just to add the numerators. When you add the numerators, you take one of the denominators. So when you do 1 plus 1, you have 2 over, you take one of these to be 2, which is equal to 2 into 2 is 1. You know that 1 over 2 is half. Half plus half must be 1. So that is why the answer is 1. But what we are saying is that they are like fractions. They have the same denominators. So we don't need to start looking for the LCM. Now, let's look at the unlike fractions. Where you have example like 3 over 12 plus 5 over 2. When you have 3 over 12 plus 5 over 2, you'll notice that both fractions don't have the same denominator. So what you need to do is to look for the LCM of the denominators. Remember, we've learned how to get the LCM. In case you've forgotten, you can have something like 2, 12. I'm using the division method. 2 into 2 is 1. This one is gone. 2 into 12 is 6. 2 into 6 is 3. 3 into 3 is 1. So to get the LCM, I need to multiply all I've used to divide them. 2 times 2 is 4. 4 times 3 is 12. So the LCM is 12. 12 becomes the new denominator. Now what you do is you take each of the denominators to divide what you've gotten from your LCM, which is the new denominator. Whatever you get after dividing it, you use it to multiply the numerator, and then you bring it down here. So if I do 12 divide 12 will give me 1. 1 times 3 will give me 3. I bring down my plus sign. 2 into 12 will give me 6. 6 times 5 will give me 30. 3 plus 30 will now give me 33 over 12. I may simplify the answer further. 3 into 33 will give me 11. 3 into 12 will give me 4. So the answer becomes 11 over 4. This is for the unlike fractions where I have two different denominators. Let's assume now that we have this fraction 7 over 2. We want to add it to a whole number, which is 4. 7 over 2 is a fraction, 4 is a whole number. We want to add the fraction to the whole number. What can we do? To make it very simple for us, we can make this look like a fraction as well by doing over 1. You know that 1 divided 4 is still 4. So you've not changed anything by dividing it with 1. It's just to give it the feeling that you are adding two fractions. You look for the LCM of 2 and 1, which is 2. The LCM is 2. When 2 divides 2, it will give you 1. 1 times 7 will give you 7. You bring down the plus sign. 1 divided 2 will give you 2. 2 times 4 is 8. 7 plus 8 will give you 15 over 2 as the final answer. When you have a question like 9 over 7 plus 3 over 4, take note of the 7 and the 4. There is something special about them. There is no number that can divide 4 and divide 7. It's impossible. There is no number that can divide 7 and divide 4. So this type of denominators are called co-prime denominators. When you have problem like this, you can choose to look for the LCM and solve the way we've been solving. You still get the answer. There is also another shorter way to do it. You multiply this and this to get the new denominator. 7 times 4 will give you 28. You now multiply 9 and 4, 3 and 7. You have your plus in the center. 9 times 4 will give you 36. 9 times 4 will give you 36. 7 times 3 will give you 21. 36 plus 21, 6 plus 1 will give you 7. 3 plus 2 will give you 5 over 28. That is the answer. If you choose to still look for the LCM of 7 and 4 and start solving the way we've done previously, you will still get the same answer. So this kind of denominators where both don't have much in common is called co-prime denominators. This is the simplest way to get the answer if you're adding fractions that have co-prime denominators. Let's look at how to add mixed fractions. Let's consider adding these two mixed fractions. 3 whole number 1 over 3 plus 1 whole number 3 over 4. How do we add the mixed fraction? For us to do that, we need to first of all convert to improper fraction. 3 times 3 is 9. 9 plus 1 is 10. We have 10 over 3 plus 4 times 1 is 4. 4 plus 3 is 7. We have 7 over 4. Now, we can look for the LCM of 3 and 4, which will be 12. 3 into 12 is 4. 4 times 10 is 40. Plus 4 into 12 is 3. 3 times 7 is 21. So we now have 40 plus 21 is 61 over 12. We can now reconvert our answer to a mixed fraction. 12 into 61 will give us 5 because 12 divides 60 is 5. So you have your 5 whole number. It remains 1. So the 1 becomes the new denominator over the 12, which will remain constant as the denominator. So this is how to add a mixed fraction. 1 over 2 minus 1 over 3. In subtracting fractions, we do almost the same thing we do when adding fractions. It's just that where we add, we now minus. So the first thing we need to do is to look for the LCM of 2 and 3. And the LCM of 2 and 3 will be 6. So 2 divided 6 will give you 3. 3 times 1 will be 3. You bring down your minus sign. 3 into 6 is 2. 2 times 1 is 2. 3 minus 2 is 1 over 6. That is the answer. This is another example, another problem on subtracting fraction. But you'll notice that this fraction is like fraction because they have the same denominators. All you need to do is to choose one of the denominators. 8 minus 3 will give you 5. So your answer will be 5 over 11. But if you doubt whether doing it this way is the answer, you want to go the long process, let's do the long process. In the long process, we'll look for the LCM of 11 and 11. Definitely, the LCM will be 11. 11 into 11 is 1. 1 times 8 is 8. Minus 11 into 11 is 1. 1 times 3 is 3. So 8 minus 3 is 5 over 11 is the answer. Let's try to subtract mixed fractions. The simplest way to do this is to first of all convert the mixed fractions into improper fraction. 13 times 2 will give us 26. 26 plus 4 is 30. We now have 30 over, remember this 13 remains constant, minus 13 times 1 is 13. 13 plus 3 is 16. 16 over 13. Now you see we have a like fraction because both denominators are 13. So we can simply take one of the denominators, 13. 30 minus 16 will give us 14. So our answer becomes 14 over 13, which we can further convert to mixed fraction. 13 divided 14 will give us 1. That one becomes the whole number. It will remain 1. So the 1 becomes the new numerator over the 13, which will be constant. So we have one whole number, 1 over 13, in subtracting the mixed fraction. Let's talk about dividing fractions. This is a bit different from adding and subtracting fractions. Remember, in adding and subtracting fractions, we make use of the LCM if the denominators are not the same. That is, if the fractions are unlike fractions. But when the fractions are like fractions, that is, when their denominators are the same, we may find the answer without really going for the LCM. But in dividing fractions, we don't talk about the LCM at all. Let's use some example to understand how we do it. Let's look at this example, 3 over 5. Let's say 3 over 5. We have 3 over 5 divided by 1 over 2. In getting the division for this fraction, we don't need to look for LCM. What we need to do is to turn this one upside down. We need to inverse it. So we used to have 3 over 5. We say this side, we turn it upside down. It becomes 2 over 1. And when you do this division sign will go, you now have multiplication sign. Now that you have multiplication sign, all you need to do is to multiply the numerators. 3 times 2 will give you 6 over, you multiply the denominators. 5 times 1 will give you 5. So your answer will be 6 over 5. If you want to break it further down, you may convert it to mixed fractions since it's an improper fraction. 5 into 6 will give us one whole number, remainder 1 over 5 as the answer in dividing this fraction. Let's try dividing fractions with whole number. If you want to divide fraction with whole number, let's assume you have 2 over 3 divided by a whole number, and that whole number is let's say 2, for example. What you do is to inverse these 2. You still have your 2 over 3. To inverse these 2, remember this 2 can still be expressed as 2 over 1. You inverse it now by making it 1 over 2. Once you've done that, you now change the division to multiplication. 2 times 1 will give you 2, the numerator, over 3 times 2 will give you 6, the denominator. You can further break it down. 2 into 2 is 1, 2 into 6 is 3, to become 1 over 3 as the final answer. It's just straightforward, isn't it? Multiplying fraction is very simple. It's like dividing fraction, but that first step of division or inversion will not be necessary because you are multiplying all straight away. If you have 1 over 2 multiply by 4 over 1, all you need to do is to multiply the numerators, you multiply the denominators, you get your answer. 1 times 4 for the numerators will give you 4, all over 2 times 1 will give you 2. So that 2 here 1, 2 into 4, 2. Your answer will now be 2. 2 over 1 you know is 2, so the answer is 2. Let's look at another example. 1 over 3 times 5 over 1. It's just straightforward. 1 times 5 will give you 5. 3 times 1 will give you 3. So the answer is 3 over 5. If you wish, you can convert it to mixed fraction. 3 into 5 will give you 1, remainder 2 over 3 as your final answer. We have 2 over 5. 2 over 5 times 6. Let's say 6 over 2. 2 times 6 for the numerator will give you 12. 5 times 2 for the denominator will give you 10. 2 into 10 will give you 5. 2 into 12 will give you 6. You have 6 over 5. This fraction is an improper fraction, so you can go ahead to convert it to a mixed fraction. 5 into 6 is 1, remainder 1 over 5 as your final answer. I am confident that you can now add fractions, subtract fractions, multiply fractions, and divide fractions. In our next video, we'll go to another topic called variation. Please subscribe to this channel if you have not done so. Feel free to like and share this video. Feel free as well to drop your comments. Tell your friends and family about our channel. Have a nice day. Bye-bye.